In lesson 1.2, we're starting with your library of functions, which is a bunch of functions that you have seen previously in algebra. And now that we're in pre-cal, you need to know them by heart. It says memorize the 8 graphs, but I don't really need them memorized. I just need you to be really comfortable graphing them. So if you don't know what they look like, you can always make a table of values. You can always pick x values, plug them in, get the y values that go with them, plot the points, and connect the dots. That's always what you can do. But these should be so you should be so comfortable with these that you basically have them memorized. This is a linear function because it just has an x value. And if we looked at a table of values, I can plug in some negatives and some positives. If I plug in -2, -1, 0, 1, and 2 into that function, then I get the exact same values out. If I plug in -2, I get -2. I get -1. I get 0. I get 1. I get 2. And so if we plot those, we see they make this straight line right there. And then connect them, connect your dots, and that's your graph. So if you don't want to make a table of values, we also know that it has a slope of 1 and a y-intercept of 0. So starting at 0, it goes up 1 over 1, up 1 over 1, up 1 over 1. So that is y equals x. We also have y equals x squared, which is a parabola. So we know this one's a straight line. We know this one's a parabola. And again, if you don't know where the points go, you can make an XY chart. Let's plug in some negatives, plug in 0, and plug in some positives. And so this says we're taking all the x's and squaring them. So if I square -2, I get +4. If I square -1, I get +1, 0, 1, and 4. And so if we plot those, -2 is at 4, -1 is at 1, 0, 0, 1, 1, 2, 4, and we see it makes that parabola U shape. And we can either have that memorized or we can remember our table of values. Here I've got x cubed. I know that that's going to look like this. But if I don't know that, then I can make a table of values. And let's plug in some negatives, plug in 0, plug in some positives. If I plug in -2, -2 cubed is -8. If I plug in -1, I get -1, 0, 1, and 8. So let's plot those. -2 is -8. -1 is -1. 0, 0, 1, 1, 2, 8. And we see it makes that snake-looking curve rising from left to right. So that is your x cubed graph. Square root, I know, is going to look like that. But if I don't have that memorized, I can make an xy chart. Now here, you can't plug in negatives because it's a square root, and we know that you can't plug negatives into a square root function. So starting with 0, 0 is the smallest number I can plug in. And I want to choose wisely with my x's because square root can give me really weird decimals. So let's plug in some perfect squares that we know are going to give us good y values. I know 0 is going to give me a good answer, 1 will give me a good answer, 4 is a perfect square, and then let's do 9 as a perfect square. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And then let's plot those. I've got 0, 0. 1, 1, 4 is at 2, and 9, which is off the graph, we can estimate is at 3. And so it makes that sideways parabola shape, but we don't get the bottom of the parabola. Then let's look at, this is called my reciprocal function because x is on the bottom. So here, again, if you don't know what it looks like, I can tell you right now it's going to look like this. It's going to have an asymptote at 0. But if you don't know, we can plug in, again, some x values and get y values out. Can you plug in negatives into a fraction? Yes. So let's plug in -2 and -1, 0, 1, and 2. Now, what's going to happen at 0? I say we're going to plug in 0, but you actually can't do that because I'm going to get 1 divided by 0. You cannot divide by 0, so it's undefined, which means there's an asymptote at 0. So I can go ahead and put a dotted line at 0. And then let's plug in -2. If I plug in -2, I get -1/2. If I plug in -1, I get 1 divided by -1, which is -1. If I plug in +1, I get 1 divided by 1, which is 1. And if I plug in 2, I get 1 divided by 2, which is 1/2. And then I can plot these points. So -2 is at -1/2. -1 is at -1. 0, we've got an asymptote. 1 is at 1. 2 is at 1/2. You can't really see the shape, but because I know what the shape is, I can curve it. So it's got an asymptote at the y-axis and at the x-axis. But if we don't know that, we could plug in more points to that table and get a better idea as to what the curve will look like. But since I know that's the shape, I don't need that many points to make my graph. Absolute value, I know is going to be a V shape. But if you don't know that, again, you can make your XY chart, and we can plug in negatives, and we can plug in 0 and positives into this. So if I plug in -2, the absolute value changes it to +2. If I plug in -1, it changes to +1. 0 stays 0. 1 stays +1. 2 stays +2. So -2 is at 2. -1 is at 1. 0, 0. 1, 1. 2, 2. And then we get that perfect V shape. So that is your absolute value function. Now we have our Euler number, or the natural base E. And so that one, you can plug in values if you want, but I know it's going to look like this shape. And let's plug in some values, although they're not really that useful. Let's plug in -2, -1, 0, 1, and 2. That's what we've been doing for the others. So if I do e to the -2, what you need to remember is e is about 3. It's 2.7. So if I think about 3 to the -2nd, then that's going to be 3 to the 2nd is 9, but it's negative, so it'd be 1/9. So it's really close to 0. This is a bad approximation. If you want to use a calculator, we can get a better one. If I plug in -1, that would be 3 to the -1st, which is about 1/3. Again, this is not a great approximation, but it tells me that it's pretty small. E to the 0, anything to the 0 exponent is 1. E to the 1st is going to be approximately 3. And then e to the 2nd, that's approximately 3 squared, which would be 9. So that'll give us a good idea for our graph. So -2 is 1/9, -1 is 1/3, 0 is at 1, and that's not an approximation, that's exact. And then the other ones are approximations. So 1 is at 3, 2 is at 9, and we can see it makes that curved shape go rising left to right. It has an asymptote at the x-axis at y = 0, so it curves down but does not cross the x. E always crosses at 1, and it rises up to positive infinity on the right side of the graph. Natural log is just a reflection of E. So if you know what E is, natural log is a reflection of that, a reflection over the line y = x. So if I draw the line y = x, which is that function, our first function in our library, then it's just a reflection of that. So natural log is going to look like this. If you can imagine folding your paper on this line y = x, E perfectly matches with your natural log over there. But let's go ahead and draw it over here. So if I know that E crosses the y at 0, I know natural log crosses the x at 0. And if E curves down towards the x-axis, natural log is going to curve towards the y-axis, and then it just rises from there. So that is your natural log graph. And this wouldn't be a very good table You could use a calculator and get some values, and just like the rest of the tables, it'll help you plot some points. Now that is your library of functions. These are functions that you need to know and that we're going to use a lot. On the next page, we're taking those functions and we're changing them. We're going to be doing different types of shifts. So if we look at vertical shifts, that is when you're going up and down. You're going to see numbers being added or subtracted off to the side, and that's going to tell you what to do. So this is going to tell me to go up 5, and this minus 3 is going to tell me to go down 3. And so we would take our absolute value graph, and we would start our vertex up 5. And then from there, I just think about what my absolute value graph does. It goes over 1, up 1, and then over 2, up 2, and we can just make our absolute value graph from there, shifted up 5. So it's as if the origin has shifted up 5, and then we do the graph as normal. We've got our reciprocal function down 3. So if I go down 3 and make a new x and y axis, which is my asymptotes, and then I know my reciprocal graph crosses at 1, 1, and then 2, 1/2, 3, 1/3, and we do that curved shape, and then we know it crosses at -1, -1, -2, -1/2, and then it does that curved shape towards the asymptotes. Horizontal shifts, that's left and right, and it's always the opposite of what you think. So when you see +2 inside, that's going to tell you to go left 2. And here we've got -1 inside the parentheses. We're going to go right 1. So we see over here that you're adding and subtracting outside of the absolute value and outside of the fraction. If it's outside, then we're going up and down. If it's inside the function, inside the square root, inside the absolute values, or inside the parentheses, or inside the fraction, then we're going left and right, and it's always opposite of what you think. So I'm going to shift this square root function left 2 units. That's going to be my starting point. And then I do my perfect squares. The square root of 1 is 1, so I go over 1. From there, up 1. From the starting point, I'm going to go over 1, 2, 3, 4, which is a perfect square. Square root of 4 is 2, so 4, 2. And then I can go over 9, up 3. So from our starting point, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. So there's my square root function, shifted left 2. Then I've got my cubic function moved right 1. So I'm going to move it right 1. And then we know the cubic function goes over 1, up 1, over 2, up 8. And then I can do the same. It's left 1, down 1, left 2, down 8. And that's all from the new point, which we shifted right 1. So this acts as our new origin point, and then we graph it as normal, like we did on the front. X-axis reflection. That is if you've got a negative in front. Negative in front of the function on the outside. That is going to shift it over the x-axis, which means it's going to reflect down or up. It's going to reflect up and down. So remember our E graph was at 1. I'm going to make an old E graph, dotted line, and we're going to be shifting everything down, or we're going to reflect it down. So instead of going up 1, it's going to go down 1, and it'll look like this. So the negative just shifts everything, not shifts, reflects it down. Y-axis reflection is if your negative is inside, negative inside, and that's going to reflect, I can't spell it, that's going to reflect left and right. So let's think about our natural log function. Our natural log function looked like this. But if I have a negative inside the function, that is going to reflect everything over the y-axis, meaning to the left. So now it'll look like this.